Okay, it's parametrics again. This is day 2. Yesterday, I gave you your first introduction to parametrics, and it was something like this. You'd have an x equation and a y equation, and what other little equation do you always have? Do you remember? Yeah, the t limiting thing, okay, the domain. The domain in this case I'll say is between 0, or equal to, sorry, underline the 0. 0 is less than or equal to t is less than or equal to 2. Okay, then that means you now have a little graph that you can make, and you can change this from a parametric equation back into the old-fashioned kind, which would be only an equation that only has y's and x's in it. All right, so one step at a time. I hope you remember that it isn't just an xy chart anymore. It's a what xy? Txy. And I'd like you to find me 3 points on the Txy chart. Choose your T's wisely. You can take anything you want, just be smart about it. I'll pause for a second while you try that. Okay, T. What are smart things to pick for T? The endpoints for sure. You want T equals 0, and that's because it's one of the endpoints here. At T equals 2 would be another very logical choice. And then something in between would make some sense. How about 1? And then if I stick in T as 0, I get 0, and 0 is 0 plus 1, and then 0 times 0 is 0. Raise your hand if you had 1 comma 0. Good. And at 1, I stick in a 1 here, and I have 1 squared is 1 plus 1 is 2. And the y is 3 times 0 is 0. And lastly, oh, that's a 1 though. Sorry. Thank you. I never put the 1 there. That's a 3. I deceived myself. And the last one is if I put in a 2. Put in 2 here, and I put a 2 here. I'll have 2 squared is 4 plus 1 is 5. And for the y, I've got 3 times 2 is 6. Now, if I graph those, I go over 1 and up 0, dot. I go over 2 and up 3, dot. And I go over 5 and up 6. Now, is that supposed to be bent like that? Yes. What in the equations would have told me that? It's a squared. You notice, though, that it's not doing the classic parabola kind of U shape? Why? Yes, there is restrictions. It's stopping right there, and it isn't continuing, but it's curving the other way. Why? Yes. You could think of it as a square root. That's kind of true, yes, but I was thinking of it a different way. You're not wrong. It's just there's another way to say that. What's different about this equation than is normally the way we write them? Yes. There is no time. That's true. But there's still x and y points that should be making a curve if this was different. Yes. Exactly. It's usually y equals something that's squared, right? Now it's x equals something that's squared, and that causes the parabola to go the different way. So if we were to continue this, just for fun, I mean, I said times between 0 and 2, but let's say that I said time could also go down to like -2. Then everybody just stick in -2 and see what you get. If time is -2, what do you get? Okay, so if you stick in -2 here, -2 squared is plus 1 is, all right, so x is 5, and y is -6. All right, so at time is -2, x is 5, y is -6. X 1, 2, 3, 4, 5. Y is -6. Whoa. Well, is there any like what is happening here? Aren't you used to graphs that are supposed to go like, and then they're not supposed to just go like whoa like that? Then what's going on? Well, let's try -1. I think this will help you see. Everybody stick in -1 on your T chart. and figure out what that point would be. -1 and -1. -1 squared is 1, plus 1 is 2 for my x, and my y is 3 times -1 is -3. 2 comma -3. Oh, see, it's what rules do these parametrics not have to follow anymore? Vertical line test. Okay, so you can have this, you can have your curve go like that, whereas before we couldn't write a single function that would do that. Okay, now that's you plotting some points and making a graph. Raise your hand if you feel like you get that part so far. Okay, good. Option B from yesterday was take the parametric and make it into, make the parametric equations, the blue ones there, into a normal x and y only equation. You can't just take this one the way it is and stick it in there. And you can't do it the other way around. You can't just take this one the way it is and stick it into there because there's no place to put x and there's no place in the other one to put y. So what do? Solve one of them for t. Which one's easier to solve for t? Top one or bottom one? Bottom one, vastly easier, because of the square root thing, you'd have to have two things because you'd have a plus and a minus, and it gets really complicated. So why don't we just take this one, solve it for t. Do you get it? T is y over 3. And therefore, we should put the y over 3 right in there. We'll have x equals, instead of t, we put y over 3 squared plus 1. Now, this is an important point. You do not have to go and solve that for y. I know you're capable of that, but it's true on the calculus tests too. Sometimes kids feel like, well, that seems like something I should do. Think it through, because if you make a mistake and you solve it for y incorrectly, they will mark it wrong, whereas if you would have left it alone, they would have marked it right. Same thing for me on this test. If you want to solve this for y, go ahead. It'll be a lot of extra work and not worth any more. And if you screw up, you have potential to lose points. It's better to just leave it. It's already solved for x, and that's okay. That is in, I guess you could call it rectangular form. It has only x's and y's. It is non-parametric form is the way we'll refer to it. Why isn't it parametric anymore? There's no t's. Okay. One more thing on your graph, we really should have been labeling. This was at time what right here? T equals 0. What was this at time what? Time is 1. What was this at time what? And this one was at time was, and if you think about it, it's time 0, 1, 2 is kind of heading that way. Going negative on time makes you go down in that way. And that's just an interesting way to think about time. Okay. So those are the two things that you learned before. So what are you going to learn today? If you had to make any predictions, how do you think, what haven't we done yet that you might think you'd learn? One person in the back is noticing that you have a calculator out. Yes, we're going to do something with calculators. In fact, let's just do that last one. That same one we just did on by hand, let's put it in on the calculator. So here's the fun part. I'm not going to tell you how. Okay. I think you can do that now. I really do. Just remember you're graphing a parametric equation. And I bet you can find it. I'm going to pause for a second while you give it a shot. Oh, and a good question is, where should we graph it from? Let's graph it from -2 to 2, because we'll see that cool curving back on itself kind of thing. So we're going to go from t, goes from -2 to 2. Only hints I will give you is once you're in the right mode, don't forget to get into the window to be able to change some things. All right, that's all I got for you. Give it a shot. Okay, a lot of kids had success with this. T squared plus 1 and 3t. I'll show you how to do it. I'm going into y equals t squared. Okay, let me find t. T squared plus 1. And then just, what was the other one? 3t? Thank you. 3t. And if I go to window, I better limit it, right? The min is -2 to the max is +2. I thought this one was intuitive enough that you could get it, and you did. Good job. Now, my graph might be zoomed out a lot. You can zoom it any way you want with the x's and y's underneath here. So I'm just going to see how it looks and see if I can see it. Oh, error. You know, the best thing to do when you get an error like this, go to. Because it'll go to the error and it'll tell you something's wrong right here. Ah, see? I could have spent time on my window thinking it was that, but it was just an extra parenthesis. The go-to thing is smart. I'm glad they put that in there. Okay. Now my window's kind of weird, so I'm seeing it kind of zoomed in from a weird angle, but I'm just going to do a zoom out. Enter, enter, and there we go. Okay, cool. Oh, what just happened there? Oh, it's still thinking. It should continue the rest of its curve once it eventually gets over its issues. Okay, so you have learned to graph a simple parametric equation. Cool. Do you think they get more complicated? Of course they do. So what happens if we had 2 functions instead of just 1? Let's say we had sine and cosine. Everybody hit the y equals and go to sine of t. No, wait, let's do a different one. Because x, think about it, which one is x normally associated with? Cosine. Let's use cosine here. Cosine. Do we want to say that again? You're on to something, I think, but I couldn't hear you. We still want the same mode, but yes, the radiance question is a very appropriate question at this point. Cosine of t. If I do it the way I have it right now, my calculator is in radians, and I just got to know that my t values that are going to go in are going to be in radians. Okay. I'm going to go sine t. I think you can find that out with a simple little touch of a button. Figure it out for yourself. All right, now that is kind of difficult to see because I've got it zoomed out so far, but it looks to me like it's making a what? It's making a circle. All right, cool. Mine stopped. Oh, that's right. I have my time limited. Isn't that interesting? I didn't have enough time to finish the circle. Okay, so I'm going to y, and I'm going to go change it from, let's say, how about we start with 0 this time, and go 0 to 2, just to get the idea. And I'm going to zoom box it, and maybe zoom in, actually, just because mine was so far out. If it started there and stopped there, do you get which direction it wants to draw the circle in? Have your circles ever had direction before? So now they do, because time matters with parametrics. All right? I really wish I could see this better. I'm going to zoom in. There we go. So that's where it starts. Why does it start there? It's putting in what? Putting in t equals 0. Could you have done this with your brain? Of course you could have. It's x was cosine and y was sine, and I can make an txy chart for it, and I would like you to. I want to just put in a couple values for it. I'd like you to try putting in 0. Remember, this isn't the time anymore. It's an angle. It's still t, but the parameter has changed. It's a parametric equation, right? So it's got that para stands for parameter. All right, so what am I supposed to do? I'm supposed to have my x value right here is the given by this. It's cosine of 0. Remember what that means? 0 degrees. That's like I'm at here. It's like an angle that never opened. And here's a dot, and it's at 1, 0, and cosine's the x of that. And so what's the answer? 1. And now, what's the sign at that spot? The sign is the y, which is the 0. So I use this equation. Sine of 0 degrees is 0. There we go. 1, 0. That's why your circle starts there. So it's important for you to understand, if you just drew this circle, you would not get full credit on your test. Your circle has direction. And so you would have to label this, and then you'd have to give it a direction like that. Does that make sense to you, that it started there? If you didn't know where it started, you could always make your calculator regraph it. And I know some people actually have a problem with that. I'll show you. All you got to do is change something on your window, and it'll regraph it. So I'm going to go to my window and make my steps different size. Instead of my steps right now are incredibly small, 0.01s, maybe I'll make them 0.1. And I hit graph, and it redraws it, and I can see where it started. If you ever want it to redraw it again, you go to your y equals, go over here, and I personally really like to change this to, and in my calculator I have to arrow down. You might just hit enter a few times and get what I say is looks kind of like a pen tip. That one. And I'm going to say OK. Why is the pen tip any better? Because it forces the computer goes slower, and it uses that little pen tip to show you where it's drawing. Especially when you have a complicated drawing that's got lots of parts to it and you're wondering where it's graphing, the little pen tip will only be in the spot where it's graphing. Okay? All right. What if I need the full circle? Has anybody figured out what time would be logical? I could make it -4 to 4, and that would work, but there's something more logical than that. Time equals 0 to, we're in radians, don't forget. 2 pi, very good. Let's go to, good. All right, so I'm going to window, and 0 to 2 pi, 2 with the pi symbol. And I'm going to hit graph. And I'm doing the little pen tip. Do you guys like the little pen tip thing? Slows it down a little bit, but it shows you direction. Do you get how on parametric equations direction actually matters? I wasn't making you show it before, but do you know on last nights you had some equations that were like this? That's got direction to it. If time equals 0 here, and time equals 1 here, the direction was that way. You know what I'm saying? It graphed from the low point to the high point. Normal graphs don't have that. So that's why I'm saying in this particular case, maybe this would be smart for you, because otherwise you graph, your circle's done, and you're like, well, but which way was it going? Okay, enough of that. And the last thing I have to teach you from changing, you changed from parametric to normal. What if you had a normal equation and you wanted to change it to parametric? Here's a normal equation. How could I change it to parametric? Well, what's it missing? A t. And it's supposed to have 2 equations, not 1. And it's supposed to have a limit on the time. Well, the way we do that is we give you 2 points on this, and we say we want you to limit it from between this point and this point. Okay? I'm going to say -1 when I put it into this equation would give me -5. That's a point on this equation, right? Here's another point. They would give you both points. If I put in a 3 on this equation, I'm going to get a 3. Would you agree those are 2 points on that equation? Okay, and you can write me a system of parametric equations that would generate the same thing. It would go from this point to that point. So, I know this is their first one, so I'm going to help. You have x equals something and y equals something. Right? That's what you need for parametric equations, an x equals and a y equals. And then you need, the t has to be limited to between something and something. T has to be bigger than this and less than that. Okay? So here's the steps. First thing, doesn't this look like a y equation except it has an x instead of a t? So that's what you do. Y equals 2t minus 3. And then if you think about what you just did there, what did you just do? You set what equal to what? X equal to t. There. That's it. That's a system of parametric equations. Now the only thing I need left is my t's. But hint, my t's aren't really t's. What are my t's? X's. And therefore, -1 to 3. Yes, sir. There is multiple ways you could have done this, but the other ways are much more complex. So, in other words, if you can find another system where if you had put in like t plus 1, and then this had been something else, that it would have multiplied out to that. Do you get what I'm saying? There is multiple ways, yes. But the other ways, oh my gosh. Not worth me spending the next 15 minutes trying to explain all those other ways. So, okay, so that's taking a normal equation, and I'm going to use a word that isn't a real word, but I think you'll get it. You're parametricizing it. Okay? It can be a word in here. So, we just parametricized a non-parametric equation. All right, so I'm going to give you one other one, and it's not, just don't overthink these. They are pretty easy. If I say it's 2t squared plus 5, and then, oh, wait, that would have been parametric right off the bat, x, and then I got to give you a couple points. Say I stick in 0 and I get 5, and I stick in, they'll give you these points. Let's say 2, 13. There. My question is, what would be a parametric system for this non-parametric equation? Write it down. Compare it with the kid next to you. I'll assign you somebody right now. All right, so here is what I would have done. First thing I rewrite is the y equals equation because it's already here. Y equals 2 instead of x, I put t squared plus 5. And then I just have to think about what I just did. X just got set to t, and that's all there is to it. You don't have to overthink these. Now, I do need a t like range here, so that's between, x is really t, 0 and 2. Raise your hand if you had that right. Good. And the last thing I have to teach you is a different kind of equation that has to be changed. Would you agree that this is a curve, and you can't predict it from just 2 points unless I tell you specifically the vertex, then you can actually figure it out. But if I give you a straight line has any 2 points on it, you could figure out what the equation would be for that, and then you could take that equation and turn it into parametric form if you wanted to. So do you get that I can take a point like 0, 2 and a point like 6, 12 and say, I want a line segment that goes from here to there using parametric form. All right, and there's the cool way I think would be to write the whole equation for it and then try to take your equation and change it from a normal equation into parametric, and that would work, but there's another way, and it's really, really simple. I'm going to show you the really simple way. And if you want to do it the more cool way, go for it. I'd love for somebody to be able to show me a simple way to take the y minus y1 n equals m times x minus x and 1, and figure out how to make that equation that you get from that turn really quick into a parametric with its limits and everything. But I can tell you the directed line segment way, x and y. Okay, I need two equations, right? And so the x part of it, it starts at 0 and it goes up 6 and you throw a t on there. Do you get what happened there? For the x, I took this and this, 0 and 6, and I said it started at 0, the starting number. It is a directional thing, so you got to know which one to start at. Okay, so I'm starting here, and I'm ending here. Okay, and then what else? Y would start at 2 and go up. Oh, wait a minute. This one's different, though. Don't say to 12. How much did it go up? 10 t. There's your two directions that you'd need. It's your two equations. It's now parametric. And now, if we wanted to, and you don't have to give these a time, you could assign time as 0 and 1 for your 2 points. But otherwise, do you get that you could kind of have the time be anything you want, really? I mean, because there's no restrictions on what time it starts and what time it ends. So they don't make you do that. So if you wanted to throw on, I know I've said parametrics always have a domain. These don't, because it's a directed line segment, and you don't have to have a time. Otherwise, you'd be kind of lame. You just always start at 0 and end at 1. But we don't even grade that part. So any other questions? So if I give you 2 points, can you tell me how do I get a directed line segment for this? Start, end, I need an x part and a y part. Okay. Mr. AO, what do you think? Okay. I'll let you watch what somebody else does this. It's not something I expect you to get after one try, but some of you will get it. Mr. B. Uh-huh. Because that's where it starts. Why did you choose 3? It went up by 3 to get to that. Very good. And then I got to throw on a t on there. Does it make sense that we need a t on there? Here's why. Because if I want to go to the next point after that, then that would be at the next increment of time, and it would go up the same amount as last time. It's kind of like a slope in a way. All right. Did you then have the other one? Who's got the other one? Only a few of you. What did you get? And it went up 15. Very good. Get that? That's the easiest thing of the day. It's not processing. It's only because you're tired and it's a Friday. Okay. So, homework for tonight. It's, I think it's 6 questions as opposed to last night's was like 4. I'm going to pause while I find it. Okay, so here we are on assignment day 2. Note, it says by hand. I can't stop you from using your calculator, but I strongly encourage you to just use your calculator to check and see if you know how to do it by hand. Okay, so do this by hand, and that requires for each of them a what? A TXY chart. And choose wisely on your T's, especially when you go here. You don't want to pick like 1. Okay, you want to do things like for your TXY. What's nice easy angles you can use? Remember the T's are angles in this context. Pi over 3. How about zeros? Isn't that pretty easy? Yeah. And then pi over 2 maybe. Pi. Eventually you're going to get to 2 pi. Because that's the ending, right? Okay, I think you get the idea there. Now let's move on to these, which are again very similar to the last ones. Just you're going to throw in, it's more trig, and so therefore be sure you pick good angles between 0. I definitely use 0, and I definitely use pi, and I just use a couple things in between. If I'm going to make you have a certain number of dots, I would say 3 is not really enough to see a curve even. I mean, it's sort of, but I'm going to say 4. I think if you have 4 dots, I mean, here, if I have 2 dots, can you see where the curve should be? No, not even close. Can you see where the curve should be now? Not really. But if I go like that, and I got 4 dots, now I can probably see where the curve is. Get the idea? So I'd say give me at least 4 points. So those are the first 4. Now here's a few more. And I think this one is, it even says extra special challenging. So it is a challenge question. You do not have to do Carl's friend Jason. And here's 25, 26, and 27. Notice 2 directed line segments. Oh, wait, 1 directed line segment. Those are super easy. And 2 where you're changing from a normal into a parametric, like we just did a second ago. You'll have to write an x and a y equation, and you'll have to have your time limit between what and what. Okay, and don't overthink those. They are as simple as you think. You just rewrite this and you make x equal to t. Okay, any questions? That's all I got for you for today.